Hello, we are the team The Buck Stops here from IIT BHU Varanasi, and this is our submission for CodeFundo Plus Plus 2018. Our web app is basically aimed at providing a helpful hand to the relief agencies. These agencies are the one who send their vehicles to disaster hit locations. So our web app basically optimizes the routes that the vehicle takes to minimize time and maximize the efforts or the help that is provided. So this is a minimalistic design where an agency needs to log in. So I'm just logging in. It's Microsoft. The password is CodeFundo. Submit. So this loads up an interface for the depot to enter its location. The depot is basically the home location of all these vehicles, from where the vehicles start. So I'm entering the location of my home institute. That's IIT BHU. And the number of members is the number of locations that the agency is aiming to help. Like for example, there are 10 disaster hit locations nearby the agency, so maybe the number would be 10. So for this case, I'm keeping the count to 9, just for an example. This line dynamically loads up a table consisting of 9 rows, 9 columns, and 3 rows. Sorry, 3 columns and 9 rows. So in each row there are 3 fields. These 3 fields signify the latitude and longitude of the location, and the third field is special because it signifies the demand. The demand can be anything like the amount of food the depot requires, the node requires, or the amount of people that need to be evacuated, etc. So in this case, we are considering it to be the amount of food required. So as you know, each vehicle would have a fixed quantity. So we are assuming here the vehicles have a quantity of 100 kgs. So they can't go on a route that requires more than 100 kgs. So I'm just entering the location of the nodes. These locations are just examples that I've taken from around my institute, but in general, these would be the location where the disaster has been hit. So I hit submit, and as we can see, this loads up a Google map, and the locations are arranged in the form of a route. So these routes basically signify the routes that the vehicles have to take. Now you may see that these are 9 different nodes, and each node is ordered by 1, 2, or 3. So that means 1, 2, or 3 signifies the specific route for which a vehicle has to take. For example, all the nodes marked with 1 need to be covered by vehicle 1. All the nodes marked with 2 need to be covered by vehicle 2, and those marked with 3 by vehicle 3 respectively. So the magic of our algorithm is that it tries to optimize the solution. Now calculating the most optimal solution is an MP complete problem and can't be done in polynomial time. Our algorithm, as you can see, did it instantly. However, this is at a cost because there is some error. We have developed this algorithm by researching from past articles, which we'll attach in the folders that we'll submit. but we